Okay, so we've done addition, subtraction, and multiplication of complex numbers. One more operation to go, division, right? And that's the fun one. So there are different ways to write division of complex numbers. Teachers will write them differently, books will write them differently. You can write it like this. 6 plus 3i divided by 2 plus 4i. That's fine. Generally speaking, I'm never going to write it that way. When I write it, I'll generally write 6 plus 3i over 2 plus 4i. They mean the same thing, but generally speaking, we write them that way. So just don't get confused by that when you see it in the book or see problems elsewhere. What's the problem with that? 6 plus 3i over 2 plus 4i. It's a complex number. Complex numbers have to be in standard form. Is that in standard form? Not even remotely. So essentially all we need is a trick to put it in standard form. Does anybody know what a conjugate is? I think in English grammar you can conjugate a verb, right? Yeah. This is different. Does anybody know what a conjugate is? Okay, essentially, if you have a complex number, say 2 plus 4i, complex numbers are called z, then you have what's called a conjugate or a complex conjugate, and you do z with a line over it. It's actually called z bar, there's a bar above it. All you do is switch the sign in the middle. 2 minus 4i. So if you're completely following me here, if you have 3 plus 6i, what's the conjugate of 3 plus 6i? 3 minus 6i. If you have 2i, what's the conjugate? Negative 2i. This is essentially 0 plus 2i. Conjugate is 0 minus 2i. So 2i and minus 2i. Pretty clear, pretty easy? Good. As long as you know that, you know your trick. So, all we do is, to get that in standard form, look at the denominator and take its conjugate. What's a conjugate of 2 plus 4i? 2 minus 4i, we just did that. Multiply by it. All of you remember your fractions from way back in, 3rd or 4th grade. Whenever you multiply something on the bottom of the fraction, multiply by it on top to keep everything equal. You're essentially multiplying by 1. So solve this all out. It just means multiply both of them twice. So 6 times 2 is 12. 6 times negative 4i is negative 24i. 3i times 2 is 6i. 3i times negative 4i is negative 12i squared. On the bottom, 2 times 2 is 4. 2 times negative 4i is negative 8i. 4i times 2 is positive 8i. 4i times negative 4i is negative 16i squared. Simplify everything out. On the top, 12, negative 24i plus 6i is negative 18i. Negative 12 times I squared is negative 1. So it's negative 12 times negative 1, which is positive 12. Over, on the bottom, negative 8i plus 8i cancels. 4, once again, I squared is negative 1. So that's negative 16 times negative 1, which is positive 16. Keep going. 12 plus 12 is 24, minus 18i. All over 4 plus 16, which is 20. Am I done? No? Why? What do you mean simplify? Yeah, essentially, this is a complex number. There's still an I in there, which means it still has to be in standard form. A plus or minus bi, which means break this up as 2 fractions. 24 over 20 minus 18 over 20i. And technically the I is supposed to be separate. It can't be part of the numerator. It has to be completely separate. I've seen people put the I on the top. It's okay, but it should be separate. And now, of course, those are fractions. Reduce them. 24 over 20 becomes 6 over 5 minus 18 over 20 is 9 over 10, I. And there you go. Complex number in standard form. Pretty easy? Again, essentially all you need to know is the trick. multiply by the conjugate of the denominator. One thing you can actually do to save time, over here, what's 2 squared? 4. What's 4 squared? 16. What's 4 plus 16? 20, which is exactly what we got for our denominator. That will always be true. There's actually a property that says if you multiply a complex number by its conjugate, your solution is the sum of the squares of the real terms. In layman speech, square that and add them together. It always has to be true. It's a difference of squares, the middle terms cancel out, and then the -1 flips the sign there and you add them together. So, because essentially you're just multiplying everything all out, if you want to save yourself a little time, you don't need to do the full foiling on this if you remember the property. Got it? Any questions? Pretty straightforward, pretty easy. The only thing I would say, check your signs and make sure you write the thing in standard form. Again, I've said this before, it would kind of be awful to get to this point, do everything right, and then lose credit because you didn't actually write it in standard form. And you will lose credit. If you write answers like that, I will mark them wrong and take off credit because they have to be in standard form. Got it? Okay, good. One more thing to do that's just fun because math is awesome. See if we can cram it all in 5 minutes. So let's see. We have the number I. And you all know I to the 1 means I, right? Anything to the 1 is just a number. So I to the 1 is I. What's I squared? -1. That's definition. What's I cubed? Huh? +1? Why? Random guess? You can do algebra on this. By definition, I cubed, using rules of exponents, is I squared times I, right? What's I squared? -1. So that's -1 times I. What's -1 times I? -I. Correct? -1 times anything is anything. So -1 times I is -I. Good. What's I to the 4th?
+1.
By definition, I to the 4th is I squared times I squared, which is -1 times -1, which is 1. Pretty good? Okay, good. What's I to the 73? Enjoy writing out a whole lot, or see the trick. What's I to the 5th?
-I.
By definition, that's I to the 4th times I. I to the 4th is 1, so that's 1 times I, which is I. I to the 6th will be I to the 4th times I squared. I to the 4th is 1, so it's 1 times I squared, which is -1. And now you should start to see a pattern. I, -1, -I, 1. I, -1, -I, 1. It will repeat. It's called the periodicity of I. Periodicity is how often something repeats. Has anybody done trig before? Sine, cosine, tangent, sound familiar? Anyone?
Yeah.
If you have and you graph them, you get waves, and you have to talk about the period of the wave, how often that wave repeats itself. Same principle here. A lot of things in math have a period. Repetition. I repeats every 4 powers. So what's I to the 73? All you do is find the highest multiple of 4 less than or equal to 73 and get rid of it, which is what? What's the highest multiple of 4 less than 73? I think it's 72, right? So this is I to the 72 times I. I to the 72 is just 1. So you get I. You're done. Nice and simple and easy. What is I to the 413? What's the highest multiple of 4 less than or equal to 413?
412.
412. So this is I to the 412 times I. That goes away. You get I. You're done. Pretty straightforward, pretty simple. Okay, this is technically speaking, not something that will ever, I suppose, really matter to any problem you're ever solving. But from a math perspective, it's really kind of cool that it works out this way. So I always like to mention it, and yes, you probably will see this on your exam as well. So just keep that in mind, because you know, it's just a fun little math thing. Any questions? Okay, good. For you guys online, you know when your homework is due for section 1.2. For section 1.3, once I post the video, I'll set up 1.3. It's probably going to be due sometime early next week. And for you guys, your homework 1.1 and 2 is due on Friday, right? Good. You're good to go. See you then.